Je vais inviter sur la scène Constantinos Coursaris et Thaddé Rolon-Mérette qui vont nous présenter. Je vais laisser leur présenter eux-mêmes ce sujet-là. Messieurs.
This is interesting. We'll try that.
See, yeah, go for it.
Good afternoon, everyone, and thank you for being here with us. My name is Constantinos Coursaris. I'm a full professor of information technologies and the director of Tech 3 Lab at HEC Montréal.
Hello, everybody. I'm Thaddé Rolon-Mérette. I'm a postdoctoral researcher here at HEC Montréal at Tech 3 Lab as well. It's a pleasure to be here presenting in front of everybody.
We are thrilled to see a full house this late in the day. Thank you so much for being here for what has been already a rich and stimulating day. We've had the privilege of actually sitting in your seats next to you and hearing all the past speakers and so many ideas from the morning all the way to just before us with Kim Reese presenting. We've benefited so much hearing on concepts from assistive technologies and accessibility, the importance of cognitive users, agentic AI in so many different contexts, all the way to, more importantly, in terms of the change that may be coming in the way we evaluate user experience and the importance of meaning. And what a serendipitous way to actually have us follow, given the program change, because that's exactly what we'll be speaking about today. So to begin, let's see a show of hands for all those of you who have worked or currently work in UX research. Think back and raise your hand if you had cases where user feedback in any form, self-reported form, said one thing, but user behavior suggested something else. Raise your hand. Oh. Mm-hmm. We have almost a full house raising hands. And that's exactly a situation that we find ourselves in quite often. It's par for the course in user experience. We typically work with diverse data sets that are not necessarily fully aligned. Here's an example. Most of the time, we end up giving a post-experience summative evaluation that is typically reflected, let's say, in the context of a questionnaire through, we heard earlier in one of the presentations about the use of the Net Promoter Score, an established industry practice, efficient, stable, reliable, to tell us at the end overall how the individual feels regarding that recent experience. But at the same time, imagine you have two different journeys before that were lived before they arrived at that final estimation. And those two journeys varied. One was smooth, frictionless, confidence building, potentially enjoyable. The other one filled with hesitation, frustration, friction, recovery. At the end, maybe the overall experience that the individual remembered, recalled, was on a comparable level as that of the other user. And yet there are so many insights that would be of particular value for design, for the design teams and beyond, if they had access, if they had visibility, if they had nuance behind that overall experience that somehow became flat and represented in a single score. So at the same time that we have this challenge, we understand that user experience research and user experience more broadly is becoming more important in organizations today. From inspiring and offering support for design priorities, to vendor comparisons, to customer experience strategy, overall investment decisions. We find that our work needs to travel across functional teams and support action quickly. So historically, we've leveraged many user feedback mechanisms, methods, such as surveys, to extract insight that could give us some of this guidance, some of this evidence-based decision. And surveys, for example, questionnaires, are familiar, they're scalable, they are often theoretically grounded, but inherently, they're subjective. They flatten that overall experience into a single score that lacks that nuance. So the interpretability and the support for action becomes quite limited. Now imagine, if we have access, and building on the previous speaker's presentation, the upstream movement that was being referenced, moving from self-reported data to behavioral data to sense data. Imagine we had physiological data that we could actually turn to. Physiological data, I could be wearing some sort of equipment that would allow the monitoring and recording of objective data that is rich and is continuous. Just like those three charts that you see here. What you see here are representations of visual paths, so where's my gaze directed at. You can see the dilation of my pupil. You can see the electrodermal activity, level of arousal I'm feeling in the moment. But it's messy, and it's hard to interpret. And what's the takeaway? How can I translate that? And even if I had the expertise, even if I had the means to collect the data and analyze the data, the post-processing time and the translation of these raw signals into meaningful insight for the end team that would like to leverage them is too overwhelming at this point. So the real gap is that we need to find sources and opportunities to complement our existing research methods in user experience that are more objective, more interpretable, more granular, going to that nuance, that richness, and also help us with two other critical items. Can we reduce the required sample size that are currently necessary for some of the existing methods? And can we expedite the translation of the data into meaningful insight? This is exactly what the mission of the Tech3 Lab has focused on over the past couple of years, in parallel, while of course supporting our industry partners with their day-to-day, more standard needs in regard to user experience evaluation. In our lab, which is a collection of experts from multiple disciplines, we take a triangulated approach. For years, we have had and continue to build and enhance the infrastructure and expertise that allows the collection and analysis of self-reported data, behavioral data, and physiological data. And we've had the privilege to work with many companies, several of which are here with us today, that span industry domains. So our approach is neither methodologically biased, nor limited in its area of application, in its area of use and deployment. What I'd like to do is give you a high-level presentation of what we have developed over the past few years, and I'll turn to Thaddé, who will give you the more mechanics, more low-level information as to this process. So what we do is, rather than speculate about a user's experience, we turn to established states that we can induce or infer on the basis of what we call cognitive paradigms. We leverage these cognitive paradigms, we record these continuous physiological data streams, we use AI classifiers, and more recently through deep learning approach, and we are able to develop composite indices, single scores at the end that produce a score similar to what would have been produced with some of the other methods that we have just discussed. But there's more.
Thank you, Constantinos. So let's start with those paradigms that Constantinos mentioned. And to understand why this was one of the most important decisions we took, we need to also look at, we'll step away a little bit from UX, just a little bit, and we'll take a look at what keeps a neuroscientist up at night, and that's the brain. There was a fantastic question earlier saying that the brain has a lot of variability. The brain is very messy, and that's very true, but it has to be this way. And this is because the world is rich. The real world is very rich. A lot of things are happening. So in neuroscience and psychology, it's hard to measure what's going on in the brain and interpret it if we just measure the real world. So for this, there are these paradigms that are used. And paradigms are these tasks that are controlled and designed to measure one state. So for example, this could be cognitive load that we discussed. This could be your attention. This could be the way you search. This could be your emotion, your arousal, your stress. And we use these paradigms. They've been validated in neuroscience and psychology. And we use them to specifically identify dimensions that are of interest to UX. For example, let's give an example. This is one of the most popular paradigms in neuroscience. It's very, very popular. It's called the NBAC. And this is designed to create different levels of cognitive load in your cognition. And the n-back is pretty simple how it works. You have a n, which determines how many letters you have to keep in your memory. So if the n is 1, the idea is that when a letter repeats itself right after, so you have a sequence of letters that appear, and when a letter repeats itself right after, you have to say, okay, yes, this is where I respond. So for example, here we have the letter A that gets repeated at one point, and the second time when it gets repeated, you say, I respond. For the 3-back, you have to keep in mind, you have to remember 3 letters before and respond when a letter had repeated 3 times before. So for example, here, the A started, we started with the A, then there was a B, then there was a S, then the A again, that's when he has to respond. It's much harder because we have to keep in our memory a sequence of 3 letters constantly. So here we generate a higher level of cognitive load. So we have 2 subtasks of the n-back where we can have low and high cognitive load. Now, when you do this, there's things happening in your brain. And these signals that are happening in the brain can be measured. And we can determine, okay, this is low cognitive load and this is high cognitive load. But your brain also sends signals to your body. It sends signals to your eye, where you look at the screen a bit differently. Your pupils dilate differently. You start sweating in your palms a bit more. Your heart rate increases, etc. Your facial expressions change. So what we did is we have neuroscience tools where we measure the brain, but we decided to identify these tools that are a bit more practical, that can be used, again, in a more accessible way. And the 3 tools, the 3 dimensions that a physiological center we use are eye tracking, EDA, electrical dermal activity, which measures sweat on the palm, essentially, and facial expression. We use these signals, and here we have to step away from neuroscience a bit and go into what keeps a researcher in artificial intelligence up at night, and that's to have a model with good prediction. So these models that Constantinos spoke of earlier, these AI classifiers, it's really hard for them to classify, again, messy data in the real world. But it's possible to classify data using these paradigms. So we at Tech3 Lab use 10 paradigms to measure 10 cognitive states. We targeted these cognitive states of interest for UX, and they're validated in neuroscience and psychology. And then we know we can use this data to create 10 different classifiers who identify levels of these cognitive states, which can be used as building blocks. So if we look at here on the right, this diagram, this model, it can be split into 2 components. It has the input, the output, and then there's the model. So the model is what keeps the AI researcher up at night. The AI researcher wants the model to be good, and that's important for us as well. So we seek a validation, and validation for here is peer review, so we try to publish. So for instance, this is the model for using the n-back for cognitive load, which will be presented very soon at one of the premier AI conferences called Flares. But that's not what's interesting for you. What's interesting for you is the input and output. The input is the physiological data. The model will pre-process it and classify it, but the output is what's interesting for you. And here it's low and high level of cognitive states. So the model gets the raw data and tells you if it means low cognitive load or high cognitive load. So we can use these models as building blocks, but again, maybe we can find something else that makes it even more interesting. We can combine them maybe. And this is where the last component of our approach comes, and it's called the inference engine, which contextualizes these dimensions into something useful, a score that can be interpreted and represents an experience or something interesting for that context. So here we can have let's restart again. So the physiological data comes in, the classifiers determine subscores, so high and low states of the different dimensions. These get used by the inference engine, which has learned which are most important, and a score from 0 to 100 is given. So this is cool, but maybe we can move on to an example so it's a bit more easy to understand, right? Concrete. So we'll go with our first example. We'll talk about 2 examples. Let's move into the world where Sylvain really loves shopping. And online shopping this time. So we had an experiment where we asked participants to do 2 types of online shopping experiences. The first one was a very good experience where they would choose their favorite websites or top-ranked websites. And the second, they would do less good experiences, what we call suboptimal, even negative experiences, which was either something like a CAPTCHA that's impossible, that would never work, or a website shopping experiences which was very bad, where we tampered it for it not to work and make it frustrating. So we did these two experiences to measure if our approach could detect the difference between these experiences and predict a score that's interpretable, that's validated. So again, we had these experiences. What we did is we identified 5 dimensions which are relevant for online shopping. We designed the inference engine to take these dimensions into account and give a CSE, which is a consumer shopping experience score. But Constantinos, what do these look like?
So to give you a visualization of what that might look like, at the end of the process, that means immediately upon completion of the task, we have a score that's generated. We have a composite score on the first website. There was an overall score that was generated by our index of roughly 50%, and the second site, roughly 80%. So clearly, there's a significant difference in the shopping experience between these two systems. That's not necessarily as exciting when you're comparing systems that are so different in the user experience they evoke. What happens when the experience is comparable? This is where the granularity that is afforded by this dimension layer perspective becomes interesting. But before I speak to that granularity, I want to speak to something that I mentioned earlier, which is the validity. So in this process, we develop our index. Great. We want to establish, is this reliable? And how do we do it? We use 2 points of reference, 2 benchmarks. We use an internal benchmark and external benchmark. The internal benchmark was in the same study with the hundreds of participants that took place in the study. At the end, they self-reported the experience via satisfaction scales and corresponding items. And they gave a score. And we saw a very high correlation, as you can see here in terms of the, over here, between the two. So for the statistics enthusiasts, you can see the results here, the correlation. So it's highly aligned between what the physiological data told us in real time with what the individual told us themselves at the end overall. And then we also tested external validity through a sort of external point of reference. We turned to a market research industry leaders established benchmark or established metric, which is the Leger Wow Index, which rates and ranks and makes publicly available through its website the score associated with the different retailers, online retailers. And in our case, you can see again the very high correlation between the established external scoring of these websites you can find online and the score that was computed by our system. So validity is assured. The alignment between the self-reports and the much larger sample than in an ecologically valid, because these are real customers of those retailers. So we've established that. But where's the added granularity? Where's the added interpretability? Imagine now 2 scenarios, 2 interfaces, 2 systems that have a comparable experience, give you a comparable score. But when you have the detail, the nuance that was afforded through that longitudinal perspective that Thaddé spoke about earlier, you can now have opportunity to identify what are the dimensions in which the system is underperforming. What are the design priorities for the next version or next iteration of this design sprint, cycle, version, whatever it may be. So what we're speaking to here is not only automaticity of the computation of a key performance indicator, but it's also diagnosticity, because you're afforded the lower level granularity into the specific dimensions that are of relevance in that particular context.
If I can add 2 more strengths to this diagnosticity. So we come back to this graph that we started the presentation with. So this is actually the output through time of the CSE, of the shopping score, from a real website. So this was website C that you saw earlier. And you don't need to just look at that final score. We can track the CSE through time, and we can set this as a parameter. So for every 10 seconds, every 30 seconds, for an example. And you see the variability, and this variability can be interpreted. So for example, the dips can be a pain point. The high points, the peaks, can be the best moments of the website for the participant. Maybe there's a gradual increase, a learning. And these can be identified through time immediately after the experiment and used as an additional strength to the diagnosticity.
Before you go, now think, for all of you that raised your hand in my opening question, think of your sample sizes, the number of participants you used in your various user experience research contexts. Thaddé? How many do we need for this approach?
So surprisingly less than you might think. So we need about 5 to 9 participants. So with 5 to 9 participants, we get a stability in our CSE score. So the way we do this is we take all the different participants, all the different websites, we take randomly, 5 to 9, and we look at until the score stabilizes. And between 5 to 9 participants, the score stabilizes at a confidence rate of 95%. So for 5 to 9 participants, a low investment, we can obtain all these strengths of diagnosticity that we mentioned. So this has tremendous impacts into the economics of UX, but also in terms of this idea that you can get something quick out the way, this fast inference that we spoke of before.
So maybe as a quick second example, just one slide, we spoke to the approach and shared an example of an index that was developed. But it's not the only product, the only index that we've developed over the past few years. And we worked in different contexts. So we chose to share an example of a collaboration, the ongoing collaboration with Deloitte, where over the past few years, we've produced the indices that you see here. We started with an earlier index that was really focused on the virality, the viral success of a system. Then there was an interest in having these automated and more immediate estimations of the user experience for localized installations, so if it was in specific configurations of technology interactions. And then there was the current need, which is about a more scalable, portable way of developing an assessment of the discoverability of the system. So just to give a little bit more about the current project, discoverability really speaks to the extent to which an individual user, let's say of a complex system, such as an enterprise resource planning system, might be able to take advantage, identify, and use effectively the functions afforded by the system. So a system that displays higher discoverability speaks to a system that allows the individual users to complete the task more successfully, faster, with reduced cognitive load, and with scaffolded, reduced initial training and onboarding needs for the individual to accomplish those tasks. Would you like to speak about the performance?
Yeah, of course. So if you look at this table here underneath, so we had, what we did is we measured 3 leading SAP interfaces or platforms, I should say. And we asked 9 experts to rank these interfaces in terms of discoverability. And then we ran our model on participants that I had never seen, so it was a context it was never trained on. And we obtained the same ranking in terms of discoverability as those 9 experts. So for example, here, system 1 was ranked number 1 most by the experts, and we obtained on average the highest number of discoverability for this inference. So it was able to match a different type of validity, a more domain expert validity, and this was, again, it comes back to this idea where it's important for us to validate these measures, not just test them in-house. And these are types of ways that we seek to obtain this confidence in what we're building.
Great. And since you did mention one of the SAP systems, we will not say which were the other 2 systems and their ranking. So, so just move forward. So what does this change in practice? What changes is now we have the diagnosticity. We have interpretable KPIs at a lower level rather than a post-summative flat assessment of the experience of the individual. That allows us now to use it as a benchmark across projects. That means across systems, across versions, across products. It also allows us to take more evidence-based decisions regarding the investment in the technologies that we're developing and the reduced time to insight, because we can actually compute those scores in real time. There's no post-processing cleaning that needs to happen, no survey data that needs to be aggregated, analyzed, and reported on. It happens in real time. And again, just to stress, we're not advocating moving away from user feedback. This is another channel, another means to complement, along with all the self-reported user feedback mechanisms, as well as the behavioral data that we can observe along the way. To conclude, just because we now have the means to do so, and this goes back to a point we heard earlier in the day about ethics, it doesn't mean we should and could proceed blindly acting on this. So here, if an organization is interested in investing in this approach to support their cross-functional teams, to support faster decision-making, more evidence-based decision-making, proper guidelines need to be considered. And that's obviously a much broader topic, but we would like to point out, obviously, that if physiological signals were to be leveraged, as we heard from our early speaker, there's already established consent process, informed consent processes likely to be in place to assure those transparency of how the data, what data is collected, but also how it will be used, how it will be stored, who will have access, governance of that data, assuring security, privacy, and overall appropriate use. So what we're talking about here is an overall responsible AI-powered UX measurement approach that, thanks to the fast pace of AI advances, we are now starting to take advantage. We're scratching the surface of what is becoming possible in UX research and the evaluation of user experience. With that, we'd like to thank you for your attention.
Pretty good.
Right on time.
Right
and
on
if
time.
I may, David, before you were very gracious in your opening remarks, I would like to take a opportunity to thank you in front of everyone for all your hard work, along with Mariko Dupuy in particular, and everyone who made this event possible. And thanks to all of you who have stayed so late in the day. David.
Merci beaucoup. Thank you, Constantinos. Thank you, Thaddé. Merci à vous deux. Ils parlent aussi très bien français. Ils n'ont pas voulu faire la présentation en français, mais ils parlent très bien français tous les deux. Est-ce qu'on a des questions dans la salle pour ces deux hommes là-dessus, sur ce sujet-là qu'on vient de présenter?
Soit en français, soit en anglais, c'est correct. Ah, grec.
Les deux, français, anglais, grec, peu importe. Pas de questions? C'est Nouvelle Index? Oui, on a une question ici. Julie, s'il te plaît.
Hi, thank you very much. I agree the difference between declared attitudes and true behaviors can be immense and important. How do you explain then that so many companies still rely on the Net Promoter Score to establish their customer experience performance? Then another question would be linked to the context of the experiments you're running. Maybe tonight, when going back home, I'll be taking public transportation and want to buy a pair of shoes with a lot of distractions and so on. How do you emulate that kind of context, and how can you be reliable in your experiments by doing so? And a third question, yes.
This is like the end-back task, right?
That's the last one, I promise, would be if these experiments are so scientific and reliable, why do you still run a UX lab instead of a multi-billion-dollar startup or company?
Can I start with the last question? That's what keeps me up at night.
Yeah, I can imagine.
No, it's actually a comment. Just all jokes aside or related to, I get that comment a lot. But I have to say, it's probably in our DNA, an academic, the intrinsic motivation in terms of the career orientation at the beginning. So I think it all starts from there.
Okay.
So we take pleasure in discovering. We take pleasure in sharing knowledge that allows advancement, whatever discipline, my colleagues in other faculties as well. So when we develop something and we do it, let's say I give an example with an industry partner and we share the IP, they can run with it on a commercial basis, wonderful. But the intrinsic reward still persists. So, and I think the answer to that last question, I know it was semi-humorous, I think that's where it comes to. But it could easily be a spin-off, and you see that a lot. You see a lot of startups in an academic space transfer out into the corporate world, as actually has happened in our own ecosystem in the past. But for the other two questions, great questions. First of all was about why do we use methods like NPS?
Yes.
It's the low-hanging fruit. It's easy, it's known. less costly than what we are proposing now.
Okay.
Let's be honest. It's much less costly. Because its technology is early, where it's not widely adopted, it's not widely known, it's not widely used. The second question is about the context of the use. If I were to rely on those measures, this goes back to the previous speaker's presentation about the relevance of context in meaning. So the question then would be, when did you choose to collect the physiological signals from those 5 participants? It would need to be in that context to give you a reliable score and the granularity that comes with it.
And so, for example, do you have a portative lab that can go along with someone in public transportation, or can you emulate those?
No, it's a great question. Since the idea had started before the pandemic, but at the time of the pandemic, because of our commitments to our industry partners and the research, to the funding sponsors of the research, what we ended up doing within a couple of months, we developed the infrastructure to allow the collection of physiological signals on the go.
Okay, okay.
Yeah, through a little blue box.
Okay, okay.
This is also
Thank you so much.
It's also
Great
why
question,
we
thank you.
identified the 3 physiological channels. Those are more transportable, more accessible, as opposed to more maybe advanced like EEG or something that has to be in the lab.
Okay, great. Thank you so much.
Super, merci beaucoup. Est-ce qu'on a une deuxième question dans la salle? Non. Merci, messieurs.
Merci.
Pour votre présentation.
Merci beaucoup.
Merci pour la conférence.